Our second factoring method is one that we call DOTS, and DOTS is another acronym. In this case, DOTS stands for difference of two squares. And that's pretty important that we make sure for each of these problems that we're going to use this method that we check that heading. So basically the polynomial that we're factoring has to be two terms, so technically a binomial. It has to be a difference, meaning it has to have a positive and a negative term. So whether it's term 1 minus term 2 or it's term 1 plus negative term 2, that's also okay. And then the last thing that we'll have to check is that the numbers and the variables in each term have to be perfect squares, meaning if I take the square root of it, it actually works and I get a whole number or a logical answer there. So if we take a look at our first example, we've got x squared minus 9, so it fits the 2. It is a difference, and what we do to check the squares is we'll go ahead and do little factor trees, and then we just ask ourselves a simple question. For the first term, x squared, what times itself gives us x squared? Well, we need an x times an x. And for the second term, we'll look at just the 9. We'll ignore the negative for now. What times itself gives us 9? So the number we're looking at here is 3. And then our answer this time is going to look different than the GCF method. We're going to create two binomial answers. So we need two sets of parentheses. And very simply, in the parentheses, whatever came out of the first factor tree comes first, so an x and an x. Whatever came out of the second factor tree goes second, so 3 and 3. And then it's always a plus in one of the binomials and a minus in the other. Simply because when we multiply, we want to get negative 9, not positive 9. So we need positive 3 and negative 3 for that to happen. So if we take a look at example 2, we've got two terms with a difference or subtraction in between. So now we do our little factor trees. So what times itself gives us 4y squared? Well, that would be 2y times 2y. What times itself gives us 49? That's the perfect square. So 7 and 7. Make our little binomials. And the 2y came first, so we write that first in each set. And then the 7 comes next. And we need a plus in one, a minus in the other. And it doesn't matter if you do plus minus or minus then plus, as long as the signs are different. Now, for our third example, when I go ahead and check this one, I notice that we've got two terms, but it's not a difference. So regardless of whether or not they're squares, it's not going to work because what would come out of this would be like t plus 6, t minus 6. The issue is, if I were to check this using multiplication, so if I worked backwards and said, I want to make sure that this actually works out, what I would do is take t times t, which will give me t squared, that checks. Then I do t times negative 6 and t times positive 6, which cancels and I get no t's in the middle. But the problem is that now I'm going to get negative 36 when I multiply 6 times negative 6. And it doesn't matter if I change this second term, because now you're thinking, okay, we'll do positive 6 times positive 6. That works out for the 36, but then in the outer and the inner terms, I'm going to get 12t because I'll get positive 6t and positive 6t. And the same thing would happen if I made them both negative. So that's why it's so important to be checking the acronym DOTS for each of these to make sure that it truly fits the difference of two squares. So go ahead and try the remaining three, numbers 4, 5, and 6, and then you can check back here on the video for the final answers. And then a few highlights for our final answers here. Notice that in example 3, we've got a variable in both the first and second term, and that's perfectly fine, so shouldn't be too many questions there. Number 5, however, I like to call this one double dots, because if you see here, this second quantity after you do the first round of dots is another dots question, because it's a difference of 2, and then if you see here I did the factor tree at the bottom, you can factor that another round. So you can see also at the bottom of the note sheet, we eventually are going to be combining methods anyway, so this is just kind of your first taste of that. So if your answer on your sheet is just this entire thing that I have here, then you just have to extend it another step and get this 2t plus 1, 2t minus 1 to add on. And then number 6, the thing that sometimes people mistake here is they put the 6c first, thinking that the variable has to come first, and that's not true. Make sure that whatever the negative term is here, in this case the negative 36c squared, that has to come after the plus and after the minus, so that we get that negative 36c squared if we were to multiply it back together.